So Euler's method and modified Euler's method. In the case of Euler's method, the formula which is used to solve the problem is y1 is equal to y0 plus h f x0 y0. Now for whatever value where x0 and y0 are the initial condition which is given along with the problem, and you have to bifurcate the value of x for which you want to calculate. So if you have to calculate for 0.3, so you will start from 0, then 0.1, then 0.2, then 0.3, and then whatever you are getting at 0.3, that will be used as that will be the final value. But in case of modified Euler's formula, there are some modifications so that approximate value of y at a certain point of x, which will be calculated, it will give more accurate. And so we have to adopt two formula for that. And suppose this is the equation that dy by dx is equal to x plus y, where x0 is equal to 0 and y0 is equal to 1. So first of all, by Euler's method, we try to find out the value of y1, means the next value of y for the next value of x. So y1 is calculated as y1 is equal to y0 plus h f x0 y0. And then by modified Euler's formula, you have to equate the value of y1 dash, which will be equal to y0 plus h by 2, because in this case of modified Euler's formula, we take the mean of two slopes. One slope is fx0 y0 and another slope is fx1 y1. Y1 is the value which we have just calculated from this formula. So formula number 1 and formula number 2 both will be used, where x1 is equal to x0 plus h. So this value can be obtained by the help of equation number 2. So once we are able to get the value of y1 dash, we try to find out y1 double dash or y1 2 value. And for that, we will be applying the second formula itself, that is y0 plus h by 2 fx0 y0. This will remain as it is. But instead of y1, we will write y1 1. And this process is repeated till we are getting the value on which we are going to agree. Meaning thereby, we will be calculating y1 dash, y2 2, y1 1, y1 2, y1 3, y1 4. And this process is repeated till two consecutive value of y1 is going to be equal. And once you are able to get the y1, then you will apply the formula number 1 to obtain the value of y2. And similarly, as once you get the value of y2, you have to find out the value of y2 1, y2 2, and y2 3, such that the two y2 is going to be nearly equal. So in this case, this problem has been solved considering that h is equal to 0.1. So first of all, the first formula equation is applied to get the value of y1. And y1 is equal to y0 plus h fx0 y0, and you are getting 1.1. Now by equation 2, you have to find out y1 1. That will be equal to y0 plus h by 2 fx0 plus fx1 y1. So y0 is equal to 1, and h by 2, h is 0.1, so 0.1 by 2. fx0 y0, if we put fx0 y0 here, so 0 plus 1, that will be 1. fx1 y1, so we will put x1 is equal to 0.1, and y1 I have just calculated 1.1, so we will be getting here 1.1. Then we try to find out y1 2. So that will be equal to y0 plus h by 2 fx0 y0 plus fx1 y1 1. Now the rest of the thing will remain same, only change will occur only in this. So we will be getting now x1 will be 0.1 and y1 1 is 1.11. So here if we will be writing 1.11, so we'll be getting 1.1105. Then again y1 3 is calculated with changing in x1 y1 2, and instead of y1 1 we will write y1 2, and so y1 2 value is put here, and so we are getting y 1.1105. Now these two values are nearly equal. It means the agreed value or the final value of y1 is 1.1105. Now once we are able to find out the value of y1, Then we start calculating the value of y2. That will be the value which will be calculated at x is equal to 0.2. So at x is equal to 0.2, whatever we will be adopting the formula number 1 to find out the value of y3. Sorry, y2. Y2 is, sorry. Oh, y1 calculate here. Now y2 calculate correctly. So y2 will be equal to, with the first formula, first equation, we will be calculating the value of y2, and y1 will be the value which is agreed value. Plus h, we know 0.1, and x1, y1 key value we will put as x plus y, so 0.1 plus, so we'll be getting 1.2316. Then with the help of this y2, we try to find out y21 with the second equation. So it will be equal to y1 plus h by 2, fx1 y1 plus fx2 y2. Now this y2 is coming over here. So we will be calculating y21, it is coming 1.2426. Then y22 will be calculated, we are getting 1.2432. And then y23 is calculated, we are getting 1.2432. So these two values are nearly equal or equal itself. So agreed value of y2, that is x is equal to 0.2, y2 is equal to 1.2432. Similarly, then we go for the third. So calculate the value of y3 by applying equation number 1. That will be coming at 1.3875. Now by applying equation number 2, we will try to find out y31. That is coming around 1.3997. And then y32, which is coming as 1.4003. And if you calculate y33, it will be again coming as 1.404 with the help of this. So agreed value of x is 3 is equal to 3 is equal to y3, and that y3 is equal to 1.404. So in this way, this Euler's formula is modified Euler's formula is applied along with the original Euler's formula. Another method for getting the solution of ordinary differential equation is the predictor corrector method. And in this predictor corrector method, we have many methods. And the first method which is adopted in predictor corrector method is the milne's method. Now, the predictor corrector method always says that first we predict the value and then we try to correct that value. How it works? If the differential equation which is given is dy by dx is equal to fxy, where initial condition is given, that is y is equal to y0 and x is equal to x0. To find the approximate value of y for the value x is equal to x0 plus h, by milne's method, we proceed like this. First of all, we calculate y0 is equal to yx0, which is given as the form of an initial value problem, initial condition. Y1 will be equal to yx0 plus h, y2 will be x0 plus 2h, y3 will be yx0 plus 3h. Now, by using the Picard's or the Taylor series method, now we calculate the value of f0, that is equal to fx0 y0. Whenever we are putting x is equal to x0, y is equal to y0, we will be getting the dy by dx. That dy by dx is known as f0. Similarly, f1 can be calculated as fx0 plus h y1. f2 can be calculated as x0 plus 2h comma y2, like this. Then the final value, that is y4, that will be calculated as yx0 plus yx0 plus 4h. We substitute the Newton's forward difference formula. So Newton's forward difference formula, as we know, that fxy is equal to f0 plus n delta f0 plus nn minus 1 by 2 delta square f0 plus nn minus 1 n minus 2 upon factorial 3 delta cube f0. And and y4, which we want to calculate, is equal to y0 plus, we are going to have a relationship, that is y4 is equal to y0, and integrating fxy from x0 to x0 plus 4h. So uh, 0 to x0 plus 4h, it is going to give x is equal to x plus nh, and dx will be equal to h dn. So right hand side, whenever we are going to, we are having here it is dx, we have to convert it in form of a dn. So dx will be replaced by h dn. So this y4 will be equal to y0 plus h from 0 to 4, because whenever we put x is equal to x0, n will be 0. And whenever we are putting x is equal to x0 plus 4h, we will be getting n is equal to 4. So this will be equal to y0 plus h from 0 to 4, f0 plus n delta f0, and so on, up to and so on, and integrating this value with respect to n. So you will be getting y0 plus h, 4f0, because f0 n will be coming. So 4f0 plus 8f delta f0 plus 20 by 3 delta square f0 plus 8 by 3 delta cube f0, and so on. And neglecting the fourth and the higher order differences. Now we have to express delta f0, delta square f0, and delta cube f0 in terms of the function. So whenever we are changing this delta f0, that will be equal to f1 minus f0. Delta square f0 will be equal to delta f1 minus delta f0, and delta cube f0 will be equal to delta square f1 minus delta square f0. And by putting all these values here, we will be getting y4 is equal to y0 plus 4h by 3, 2f1 minus f2 plus 2f3. I have not calculated the value, I am writing it directly. If you want, you can check it by considering the difference equation and putting the value of delta f0, delta square f0, and delta cube f2. So you will be getting this value. That is the y4 is equal to y0 plus 4h by 3, or 2f1 minus f2 plus 2f3. Now this is called predictor. This value which we are getting is the prediction of the y4. Now once we are able to get the predicted value of y4, we obtain the first approximation as f4 is equal to fx0 plus nh y4, and a better value of y4 can be found by the Simpson's rule, as it says that y4 is equal to y2 plus h by 3 f2 plus 4 f3 plus f4. Now this is the corrector. Thus, an improved value of f4 is computed again, and a corrector is applied to find a still better value of y4. Now we repeat this process till y4 remains unchanged. So first we apply y4 for first value, then we apply y4 for the second value, until unless we are getting the correct value. So first of all, we will be calculating the value of y4 with this formula, which is a predictor value, and then applying this particular formula, which is obtained by the Simpson's rule, to find out the corrected value. So let us go with an example of the milne's method to solve a differential equation. The differential equation is given as dy by dx is equal to x minus y square, and the range is given as of x from 0 to 1, and the boundary condition or the initial condition is given that x is equal to 0 and y is equal to 0. So by using the Picard's method, we can write y is equal to y0 plus 0 to x fxy, where fxy is equal to x minus y square. To get the first approximation, what we do, we put y is equal to 0 in fxy, and whenever we are putting y is equal to 0, we will be getting it x, and x is also equal to 0. So y0 will be equal to 0, and this fxy will be equal to from 0 to x into dx, because we are putting y is equal to 0. So this x dx, whenever it is integrated, we will be getting x square by 2. So once we are able to get the x square by 2, it means y1 is equal to x square by 2. So what we'll do, replace this y by the new value of y, approximate value of y, that is x square by 2. So it will become x, y2 will become x minus x to the power 4 by 4. And whenever we are integrating with respect to in between 0 to x, so we will be getting x square by 2 minus x to the power 5 by 20. Similarly, third approximation we can get by putting the value of y2 as x square by 2 minus x to the power 5. So by in this particular equation, that is x minus y square, we are putting the value of y. So we are getting x minus x square by 2 minus x to the power 5 by 20 whole square, and then integrating with respect to x. So we will be getting x square by 2 minus like this. So in this way, you are able to calculate y1, y2, y3. Now you have to find out the value of y4. Now let us determine the starting value of the milne's method by choosing h is equal to 0.2. x0 was 0 and y0 was 0, so f0 was also 0. When x1 is equal to 0.2, y1 is equal to 0.20. So we will be getting the value of f1. Then x2 is equal to 0.4, y2 is equal to 0.795. So f2 is equal to this. x3 is equal to 0.6, y3 is equal to, how we are getting x3 and x1, x2, because we know x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h. Similarly, I have also shown you that what is the value of y1, here y1 is equal to y x0 plus h, y2 is equal to y x0 plus 2h, y3 is equal to y0 plus 3h. So in this way, we have calculated the value of, and once we are able to know the value of x1, y1, we are able to get f1, we are able to get f2 and f3. So how you are calculating the value of y1? y1 is equal to x square by 2. So we are putting the value of x as 0.2. You will be getting y1 is equal to 0.20. And similarly, y2 you have calculated as x square by 2 minus x to the power 5 by 20. So putting x is equal to 0.4, you are getting y2. And once you are getting x1, y1, x2, y2, you will be able to get the value of f1 and f2 and f3. And once you got all these three values, you can apply the predictor formula to get the value of y4, that will be equal to y0 plus 4h by 3, 2f1 minus f2 plus 2f3. Putting all these values. So at x is equal to 0.8, you are getting the value of y4 is equal to 0.3049. X is equal to 0.8, y4 is equal to this one, and f4 is equal to this one. Now, this y4 is calculated by putting the value of y0, h, f1, f2, and f3, so that you are getting value of y4. Now, whatever value of y4 you are getting, that is corresponding to the value x is equal to 0.8. And corresponding to x4, that is 0.8, and y4, 0.3049, you are able to calculate the value of f4. Once you calculate the value of f1, f2, f3, now you apply the corrector formula. Corrector formula is y4 is equal to y2 plus h by 3, f2 plus 4, f3 plus f4 by Simpson's rule. So y4 is equal to, you will be getting 0.3046. And at this particular point, f4 is equal to 0.7072. Now, using the corrector method, you have got a y4 is equal to 0.3046. Now, again, we apply the predictor method to find out the value of y5, because you have to calculate the value of x is at value of y at x is equal to 1. So you will be applying the predictor formula to get the value of y5. So at that x is equal to 1, whatever value you are getting, that will be value of y5, and correspondingly you try to find out the value of f5. And once it is done, now you apply the corrector's formula for calculation of the value of y5, that is equal to y3 plus h by 3. Now we know f3, we know f4, we know f5. Putting all these values, you will be getting y5. And once we put x5 is equal to 1 and y5 is equal to this, we are able to get f5, that is 0.57925. So the value of y at particular one, that will be equal to 0.455. So this is how the milne's method of predictor and corrector method is being applied to solve the ordinary differential equation.